All right. Today we're going to introduce Campus with RSA. The topic is toward a software-defined infrastructure. We're going to introduce how we use Campus to orchestrate the rack scale architecture. Traditionally, we have a computer, in the 80s and 90s get popular to the personal desktop, and then client server model, and then evolve into a data center scale computing, like Google and Facebook's cluster of the computers. As we evolve, the technology also evolve with this increase in the computing. And the challenges for the data center is that it's getting complex over the time. Now we would like to reduce the cost, and in the meantime we're going to maintain an increase in the data volume, in the application growth, and also along with that it's going to be your operation cost is going to increase, due to the scale and also the complexity of your applications. And in order to administrate that, the management and the admin cost, is like 8 times more. So we're facing a challenge here. How do we maintain or decrease operational cost while still, to accommodate the increase of the computing scale and the application complexity? Now here comes Openstack, which is an open source platform for like large scale cloud operating system. Openstack, when you look at it, is just a way of solving the kind of infrastructure layer problems. And there are other technology like methods trying to address similar situations. Trying how to schedule a many tasks in a pool of computing resources. Now, there's a trend in the software industry and the product stack is that we're going to have software-defined infrastructure. The idea is that the infrastructure is no longer fixed, physical resources. Rather, it's going to be virtualized building blocks where your compute, your storage, and the networking could be on-demand created, and those could be driven by software. It allows us to build more powerful infrastructure to accommodate more complex networking requirements or computing requirements. Now, in terms of the composable software stacks, we take OpenStack as an example. Here in the OpenStack compute, you may have Nova, with necessary agents, and you may have storage like Ceph as a storage solution, and for the networking you may have a Neutron agent or OVS switch and other SDN controllers. And in order to put all these complex software together and working smoothly, so you have to have a different set of software to drive them, to orchestrate them. Okay, here we have technologies such as Ansible, Chef, SSCM tools, and that's to any developer or sysadmin is getting more complex. It's a daunting task to get everything right and also perform well. Now Intel introduced this concept is that, at the hardware level, we could also make the resources composable. The hardware is no longer a fixed box of 2 CPU, 8 cores, or 64 gig of RAMs. Rather, we would on-demand create what is called a machine out of a pool of drawer of resources. And this particular talk today we're not going to detail of RSA. I have put the information here for a talk on Wednesday, which may go more details about internal of RSAs. But the concept is that we can on demand, compose or decompose the resources out of a great, a few racks of, resource pool. Now, what Compass does here is to accommodate this new generation of hardware infrastructure, software infrastructure with intelligent software. As we mentioned before, in order to configure those physical resources out of, for example, RSA, composable hardware resource pool, and then lay over a software layer, which is Openstack, virtualization, of computing resources and networking resources. Things are getting out of control without necessary tools to automate that. What Compass come into play is we try to be the bootloader for your data center. Imagine if you have a PC, you need a bootloader to load your operating systems from a coding image or from an ISO file. Compass allows you to do similar things at a larger scale. So you have a blueprint of your networking and computing and overall infrastructure. We automate that for you. So on the high level, Compass addressing the problem by taking care of 3 areas. One is that I have the hardware level composition part by, for example, RSA or other mechanisms. And we do some level of resource discovery, resource management, so that as a user, you're going to have visualize the topology of your, for example, physical resources, like your switch and other resources. And then you're going to install software, right? Openstack is just one example of the software stack. Could be Mesos, could be other distributed systems. Another area that Compass would help take care of is how to provision that. You have a bare metal machines, and then how do we install operating system on top of that? And then once you have that, of course, you need to make sure the IP address assignment and follows certain IP address management scheme and other things. And then once you have that, you may want to install additional software package on top of that. Openstack is just one example of it. Openstack is very complex. So Compass will have high-level abstractions to provide a user-friendly way of configuring OpenStack. For example, OpenStack may have a different mode of operations. You may have a single controller with multiple compute node, or you may have a HA where you have multiple controller, and then you have achieving the high availability for your OpenStack cluster. Compass hide all the configuration details for you, and then we simplify the task so that an end user could use the software to automate the SDA infrastructure. And this diagram shows internal architecture of Compass. I'm not going to cover the details here, but please note that the Compass core is open source software, is available today, and then we have extensible architecture. In the diagram, we say that for the hardware management, we could use a switch plugin where we use SMB queries to figure out what is connected to machines, topologies, and things like that. But with RSA plugin, which we're going to demonstrate later today, is that we rely on RSA's improved capability to expose very granular level resource information to our user. All right, so that's just for us, it's just extension for Compass Core by putting an RSA plugin to enable the RSA capabilities. Similarly, for OS provisioning, today we support Cobbler, which is a wrapper of Pixie, and hiding those details. But we're also working on using OpenStack Ironic project, which is another OS provisioning tools, to do the job. And for package deployment, we have Chef or Ansible plugin. I'm not going to cover the details. Now we're going to hand over Grace for a video demo of what we have done with Intel RSA team, where RSA plugin is added to Campus, and then Campus will do the resource discovery through RSA API, and then Campus allow user to follow a very easy to navigate wizard to configure Openstack cluster out of the RSA resources. All right, hand it over to the video demo. So in this demo, we're going to demonstrate RSA provisioning flow using Campus to install Openstack. All right, so once you log into Campus, you're going to have different menus, and one of it is a switch-based resource discovery. We're not going to cover it here. Rather, we're going to use RSA to discover the physical resources where RSA would provide a rich set of API for us to expose very detailed information about those composable hardware resources. As you can see, once the server discovered, here there are 3 machines discovered from the RSA API, and then you can navigate to the physical resource menu on the top, and then you're going to see the detailed information about the resources. In this case, you have front view where you have 3 drawers, and then you dive into the drawers. You're going to have different modules. Each module may have multiple processors, RAMs, and other resources. You can mouse over to get the details. And this is all provided by RSA APIs. And then if you go back, you're going to see in the back view, we have information about the thermal zone, the fans, and mouse over, get the detailed information, or we can get a power unit information. Again, everything is through the APIs. Okay, so what this plugin does is to expose this information to Campus, so that when Campus user would have the overview of, for example, resource utilizations of the whole RSA resources. Now let's move on to try to create OpenStack cluster. Here we have different systems. We're going to choose OpenStack Icehouse release, and then we're going to choose multi-node cluster as a OpenStack flavor. And then you can see right now you're entering a step-by-step wizard where we're going to select the machine that is available. In this case, you can also, from this UI, you can expand and review similar information that you saw earlier about the detail of the resources. Okay, this is again provided by RSA plugin. And then, once you select, in this case, 3 machines, we're going to move to the next. At this step is kind of OS global configuration for your cluster. So we're going to information about NTP servers and other things. And here we're using a local repo for the packages. All right, going to the next step. And this is the networking configuration about your OpenStack cluster. How many subnet you have. You have tenant network or management network. So in this case, we choose 2 interfaces. And then we're going to specify what is the IP ranges for the subnets. All right. So, and as we put the information in, we're going to see you can assign the IP addresses here. You can do it manually, or in this case, we have autofill, which is very useful if you have, let's say, hundreds of machines. For the 3 machines, you may not need it, but for hundreds of machines, you don't want to type one by one. All right. So we got it here, and then we override the host name. We're gonna say controller, and then compute 1 and 2. All right. So once this is kind of networking configuration information for your cluster, we move next to the partition information. In this case, it's very simple, and we're not going to change it. And then here, the Tucker system, what we mean here is OpenStack, because we're going to install Icehouse cluster here. This is a credential for the internal modules. We're going to keep the default. And also, this is Keystone user credentials. Again, there's default value we're not going to change. And then for the neutrons, there's the option to use VLAN or GRE tunnels, and then we're going to choose GRE. All right. So here, once we have all the information, this is what is called role assignment, which means in the controller you're going to have the Keystone and other processes. For compute node, you're going to have LOVA and network agent, and we put in proper resources. I mean the role names allocation here. And then next step, where we get all the information, and then we need to map the two networks that we have to the OpenStack terminology. What is a storage network? What's a tenant network? And once we have the mapping, of course, everything behind the scenes kind of set of config files, but we simplify this. And then here, this is where you can overview all the configurations. You can go back and change if you want to make changes, and then you can review the very details. And this simple to use kind of wizard hide all those configuration details. You may have to touch maybe 50 different files, right? So here, just a very simple, like a few steps. Now we're going to report the installation status for you once you power on the machine, and then do the PXE boot and the OS and then package installation. And once everything is completed, you're going to see, okay, this is a fast forward, of the installation process. Everything is cool, green, 100%. Okay, so now an operational OpenStack cluster is available. This is just a standard OpenStack Icehouse UI here. All right, so we're not going to show the rest. The rest is standard OpenStack UI. All right, so that's all for our demo, and we welcome any questions on this topic. Thank you.